Hey guys, I know we're not doing a test today, so we're going to move forward with a little bit of the material. Hopefully, we will review um, in class on Monday. If not, we will conference through Schoology on Monday. And if you don't know how to use the conference tool, send me an email and I will try and get you guys up to speed. As far as things that would have been due today, the extra credit assignment, I've created a turn in option for you under extra credit assignment. So I've adjusted that. Please turn in 3 pictures of your project, right? Preferably one where I can clearly see the detail, one that you're in the pictures so that I know that it's your project, and then one where I can read the description that's supposed to go on the bottom. If you guys turn that in today, you will get your points accordingly. All right? I know some of you guys were a little concerned about that. All right, so today's lesson we're going to keep pretty brief. I'm going to review the things that we did in class the other day, get into a little bit more, try to emphasize some things that you still want to be thinking about for the test, and then we're going to wrap up. So I'm going to try and keep this to 15 minutes. I'm already a minute and a half in. So, when we were talking the other day, we got through the idea of longshore drift. We got through riptides, backwash, and breakers, and all that good stuff. Then we talked about tidal flats and some of these other features that you'll find at the beach. So, again, we all know when we think beach, it's either sandy or it's rocky, which is true. But let's not forget that you can also have tidal flats, you can have these lagoons, and today we're actually going to get into marsh and some of the organic landscapes that you actually have along the shore. All things that we can see around Long Island, so all super relevant to us, whether you forget about earth science in 3 months or you decide to stay passionate about it for the rest of your life. You'll certainly interact with it here on the island. This diagram I wanted to pull back up. Just want to zoom in a little. I want to remind you that diagrams will be on your next test, and something like this is super, super helpful, at least from my perspective. When I'm looking down at this, I think that understanding the different types of waves, right? These are your oscillating waves, right? And then over here, we have our translational waves. So I'm going to call them my TWs. Over here, you're seeing the breaker, right? This is this intertidal zone, right? Over in here, that difference between high tide and low tide. Out here in the back, you have the lagoon. So this is a lagoon that's actually separated and protected. Just to give you a quick reference, Fire Island is a barrier island. Typically, a barrier then separates the sea from a lagoon. So it's almost, don't hold me to it, but the Great South Bay, that section that you're crossing over when you go over like the Robert Moses Bridge, that's almost, in essence, a lagoon from Fire Island. Some other cool features in here. We got our marsh, showing the vegetation back there. Dunes, if you guys didn't know what dunes were, now you do. They're super important in the protective feature of a barrier island. All right, enough drawing. The features that we talked about with longshore drift, that idea that we're carrying sediment along because the waves are approaching at about 45 degrees, and because of the variation in wave velocity, we still get a slight angle pushing sediment along the shore in that sawtooth pattern. If you need to take a look in the text, Marshak articulates that really, really well. Otherwise, in a conference on Monday or in class, we'll hammer that one out a little more. But this creates our sand spits, or what I call just spits, where you have this stretch of sand that extends out into the water. Your barrier island, like I just said, Fire Island is our barrier island. So that is going to parallel the shore, but it's offshore. A spit is still connected to the shore. If you're trying to pick things out in a diagram. Your lagoon is going to be the area behind the barrier, and then your tidal flat, that broad area, that it's going to be pretty flat. It's going to stay underwater or slightly underwater, submerged during low tide. As we said, sediment budget. That's just that in and out. A lot of terms get reused. We just change the exact meaning. So when we talk about budget, if it's sediment budget, it's the in and out of sand. In other chapters, we talked about water budget with groundwater, so on. Then we talked about rocky coasts and the idea that some coastlines get hammered by waves, and you have these high cliffs that basically get eroded away. So that wave erosion takes all the small stuff and leaves the big chunks of rock behind. So your North Shore beaches, right? If any of you have been up to Comsec or some of those other beaches, you got a steep cliff and then lots of rock. Now, looking at this diagram, thinking about your test, I like the fact that you can see over here the headlands. So this whole protruding portion of land moving out. And then, just going to erase that so that it's clear. And then over here, this inner portion in here is your embayment. Now, in a young coast, geologically speaking, you can get this variation. Over time, the longshore drift is going to actually flatten that out. So that's what we're talking about in this note here. Many rocky coasts start out with an irregular coastline. So that's the headlands out into the water, embayment, cut back, and then over time they even out. By the way, if I'm going too fast for you, you can always hit pause, go back, listen to it again. All right, and your take-home messages. Again, these are always things that Marshak said, hey, before you leave this section, you should understand. And I think it's good for us to focus back in on that. So great variety of landscapes. Longshore drift leads to sand spits. Also is going to lead to barrier islands. Those are like the two big things I'm seeing here. We did not get into estuaries. We did not get into fjords. We've already talked about those, so I didn't want to belabor those points. Now, the key material for today. Along countless shores, an abundance of resources can arise in a vast, diverse population of organisms. What the heck does that mean? It means that along the coastline, we're going to have all these different organisms, plants and corals and little crabs and clams and all these guys coming together to create their own little ecosystem. And for Long Island, that's super important. If any of you like to kayak out in like the Peconic along the South Shore, you'll find we have a lot of marsh that surrounds the island. It's really cool because you can like paddle in there, paddle out. And in that marsh area where the coastline is being protected because the marsh actually absorbs a lot of that wave energy, but in the process creates a unique ecosystem. Really good. If you read this passage, they explain that 10 to 30% of the organisms basically breed in marshes in the ocean. So what I'm describing here, this control, this protection of the shoreline is what we call an organic coast. So you're seeing that right there. Nature of the organic coast depends on the organisms in the area and the climate. So for us, our organic coast, we're at a higher latitude, so warmer. We have warm water, but not like super warm water. We are going to end up with this marsh. If we were to go down below 30 degrees of latitude, that's where the reefs come in. So, a couple other types of features here. I focus in on marsh because that's the dominant overarching term. Wetlands. So, a vegetated, flat-lying stretch of coast that floods at high tide, becomes partially exposed at low tide, and does not feel the impact of strong waves. Now, I got to make one quick note. These two should be switched. Right? A marsh is dominated by grasses. Swamp is dominated by trees. Right? Marsh dominated by grasses. Swamps dominated by trees. Hopefully on Monday I'll have time to tell you a story about my experience going through the swamps, but not today. Bogs you'll also find around Long Island. Up on the North Shore, there's some really good bogs. But this bottom one talks about mangrove swamps. And those are going to be found in the tropical, subtropical climates. Actually, down by New Orleans, there's a tremendous amount of mangrove swamp. And they're really cool because they're trees that can live in fresh and salt water. So they actually rise and fall with the tides. If you guys again look in the text, there's some really cool pictures. But during Hurricane Katrina, there's a tribe of people that live down by New Orleans that actually took all their stuff, collapsed all their stuff down, went into their boats, and then anchored themselves into the mangroves and weathered the storm in there. Because as the waves came in and the sea level rose, so did the trees, and so did the people. And then when the storm was over, right, it came back down. They paddled their way out. Really, really cool story. Wish I had more time to explain it to you, though. So, mangroves, swamps, marsh, bogs, all different aspects of wetlands. Coral reefs, though, are where we're actually going to be anchoring things down in the water at depths up to around 60 meters. These are going to be found in the latitudes below 30 degrees, so that's what this diagram down here is trying to show you. And we mentioned the other day with ocean acidification that coral reefs are in jeopardy. That is because coral reefs are being built by these little organisms that are secreting a biochemical limestone. They're secreting calcite, which we know will dissolve with a mild acid like hydrochloric acid. So, I want to remind you, all these different points that we talk about are connected. Now, coral reefs developing in warm, shallow, clear water. Can't have pollution in there. Can't have a lot of acids in there. So they're there to protect the land. So again, another function of organic coastlines, absorbing wave energy and protecting the coastline. The largest reef in the world is the Great Barrier Reef down in Australia. Right, it can extend for, saying 2,000 kilometers or about 1,200 miles. So that's pretty substantial. Even in Hawaii, there were a lot of reefs that you could snorkel around. I personally didn't do that, but other people that are into the sea and want to see it, it's absolutely amazing stuff. So as I said, we're going to keep this brief today. It was just one little section. It moves the chains a little, and then we'll review on Monday for hopefully a test on Tuesday. I'm crossing my fingers. Hopefully you're crossing your fingers, because I gotta tell you, I miss you guys. So, organic coasts, place where living organisms control landforms along the shore. Good to go. Some organic coasts consist of wetlands in the intertidal zone, host to grasses, which we said were going to be our marsh, mosses and shrubs, which were going to be our bogs, mangrove trees, which are their own category. But depending on which one we have, we need to look at the climate to figure out which type of organic coast we should expect. And then our coral reefs, as we just said, were developed in warm, shallow, clear water. I am going to leave you guys here, and you have a practice test to work through. So please spend a little time with that. This weekend, continue studying. Right? We don't know what Monday brings, and when we do, we'll adjust accordingly. All right? Hope you all have a great weekend. Bye-bye.